With the skin modifier applied, it's time to fine-tune the solution. Since you'll be concentrating on the left leg, you may want to readjust the animation timing to focus on its motion. Leg motion is taking place between frames 0 and 640. You can use the time configuration dialog to refocus on that time. You can also use shortcuts by pressing Ctrl-Alt and then left click and drag or right click and drag the timeline, depending on whether you want to reset the first frame or the last frame of the animation. With the foot selected, make sure you are in envelope modes and that vertices mode is enabled. Scrub the animation to view the problems. The worst is happening at the heel and ankle levels, but even the toe joint needs some adjustments. Usually, at this point, you want to block out the skinning. This means you want to manually select and assign vertices to their closest bone. Once this is done, you can go back and adjust the blending. To select a set of vertices, you can rely on region selection. However, the rectangular marquee may not necessarily be the best option for vertex selection. One universal favorite for this kind of selection is the lasso tool, although others can be equally practical. Another selection method you'll be using extensively is the ring-loop combination. If you select two adjoining vertices, you can use ring or loop to select other vertices on that loop edge. This is an incredibly powerful selection tool, but it only works if the character was modeled properly. Even if it was, the ring-loop selection method is not perfect, as it fails when the triangulation inevitably is not perfect. A good example is around the ankle, where you can see the 5-edged vertex. Triangle loop selection there will fail, which means you still need to rely on conventional selection methods sometimes. In some situations, you may even need to revert to vertex by vertex selection, using Ctrl or Alt to add or remove from the selection. For now, and using the lasso tool, select the front part of the foot. The selected vertices appear as white boxes. Here's a bit of a quick tip. Notice that if you orbit around, the selected vertices are not necessarily acting as a rotation center. Even with the orbit tool set to orbit around the subselection, this doesn't seem to work with skin vertices the way it does with mesh vertices. The trick here is to set the transform center to work around the selection center to get the orbit to work as expected. With the toe vertices selected, what you need to do now is to fully assign them to follow the toe bone. Select the toe bone. Since it's named properly, you can select it from the list or simply by clicking it in the viewport. Notice the absolute effect value. It may already be set to 1, which means this bone is affecting the selected vertices 100%. Just the same, set this value to 1 and press Enter to confirm it. Next, select the rest of the vertices on the foot and heel, but leave out the top vertex loop near the ankle. Now select the foot bone. Notice this time that the absolute value doesn't actually show any numbers. This is an indication that the selected bone, foot bone, affects the selected vertices by various amounts. Again, set the value to 1 to ensure all selected vertices follow the selected bone. Finally, select the vertex ring at the top and assign that to the knee bone. Test the animation. There are fewer problems now, but you still need adjustments. This is where you start fine-tuning the joints. Go to frame 20 and take a look at this loop and how it's sort of crashing into the foot as the toe springs up. Similarly, at frame 60, the same loop is rotating a bit too much with the toe. This loop should be slightly affected by the foot bone, the same way the adjoining loop, which is currently following the foot, should be made to bend slightly with the toe. You can do this in a couple of different ways. One way is to continue using the absolute effect value by selecting a loop of vertices, then a bone that should affect the selection, and finding the right value by clicking and dragging the spinner in the command panel. Another way is to use the Weight Tools dialog. Make a vertex selection and also select the bone you want to affect the vertices. Here, instead of a click and drag, you can click a preset percentage button, such as 0.5 for 50% or 0.25 for 25%. This dialog shows you how many bones are affecting the selected vertices and by what percentages. You are not restricted to presets. You can force a custom value, or you can scale the weight up and down to increase or decrease percentages. Ultimately, whether you use the weights tool or the absolute effect value, you're still relying on a visual medium. It basically has to look right in the viewport as you run through the bone's range of motion. The rest of the foot is pretty rigid except for this area around the ankle. Here, you probably need to make a selection using a conventional approach, as the loop option will fail, as discussed earlier. At this point, these vertices are affected 100% by the foot bone, but they should be made to react to the knee bone by a small amount. Select the knee bone and adjust the weight value. About 30% should do fine. If you feel some vertices need a little more or less weight, adjust them as well. Always test the weights in relation to the animation of the joints by scrubbing the animation slider bar. When you're done, exit Edit Envelopes mode. Go down the stack to Editable Polygon Subobject mode, and click Unhide All to bring back the mesh into view. Exit Polygon mode when done and save your file. In the next movie, you adjust the bottom of the leg and the knee joint.